Hi everyone, in this video we're going to go through some challenging questions. So these aren't taken from your textbook, they're taken from a different textbook, but they're similar to exam type questions. So it's really good to go through them. I don't think I chose any multiple choice ones. Most of them, or all of them, are short answer questions. So hopefully that'll also help you for your SAC, because your SAC isn't multiple choice either. Don't worry too much about the numbering. It's just what I've taken, where I've taken it from the textbook, just for my own reference if I needed it. So let's make a start. All right, so the following table shows the data collected from a random sample of 8 Year 12 students in a school. All right, so we've got all these variables. Now it's extremely important that we know how they're defined. So gender is okay, female, male, or other. Phone number is phone number of the student. Number of family members, living at home, the language spoken. So we've got English, Mandarin, but they've been allocated a number, and then the distance each student travels to school from their home. And distance is measured in kilometers, which is important. All right, so we can see with this question we've got, we want to define the variables, the type that they are. So continuous, that would be numerical continuous. We've got nominal. We're looking at some other things, but let's just have a look at the types of variables that we have. All right, so let me just open this. So when we're classifying variables, just remember you've got categorical, numerical, and then under categorical you've got nominal or ordinal, and under numerical you've got discrete and continuous. You can use this little map to help you decide what type of variable they are. So you got your variable, are numbers involved? Yes or no? And then you just work your way through to help you decide. So the first question was, let me just go, where are we? Listed variables in this data set that are continuous, and then we've got the ones that are nominal. Let's just have a look at each one. So gender, if we're working through the mind, it's not a mind map, working through this algorithm, are numbers involved? No. So it's categorical. Then we've got to decide whether it's nominal or ordinal. Is there a natural order? Well, we're looking at gender, so no order, so it's nominal. All right, phone number. So this is a tricky one because often when we see numbers, we think it's got to be numerical. All right, so are numbers involved? Yes, they are. Does it make sense to calculate summary statistics? So is it normal to calculate the mean phone number, the average phone number? Well, no. All right, so it's got to be categorical. Is there a natural order? Well, no, not really. They're phone numbers, so it's just nominal data. So the phone numbers are just a bunch of numbers that we use to call people. All right, it doesn't actually mean anything. All right, number of family members. So we can see numbers being used, so let's go through. All right, are numbers involved? Yes. Does it make sense to calculate the summary statistics like the mean? Yes, it does. So we've got numerical. Is the variable measured? Well, no, we're counting them, so it's discrete. All right, so family members, number of family members is discrete. Now the language. So we've allocated a number to the language. So let's, oops, where am I? Go back to here. All right, so we've got a number. Are numbers involved? Yes. Does it make sense to calculate the summary statistics? Now, those numbers are just identifying a language. It would be the same as if we allocated a letter. So instead of allocating one, I think it was English, we would allocate the letter E to English. So no, it doesn't make sense to calculate the mean, so it's categorical. Is there an order? No. So it's just nominal. Oh, keep going to the wrong thing. Back to here. All right, and then the distance. So, and it's being measured in kilometers. So going back, are numbers involved? Yes. Does it make sense to calculate summary statistics like the mean? Yes. So it's numerical. Is the variable measured in units? Yes, it's measured in kilometers. So it's continuous. All right, so you can use that to help you answer questions like this. So the variables that are continuous, just distance. The ones that are nominal, so gender, phone number, and language. So 3 are nominal. and then we've got discrete here. All right, what percentage of those who identify as male speak English in the home? All right, so percentage of those who are male speak English. So we've got, what was the number? I think 1 was English. So we've got a male here who also speaks English. They've got another male who also speaks English. We've got a male doesn't speak English. Well, might, but might not be his first language. And then another one. So what we're looking at, what percentage of those who identify as male? So we've got 4 who identify as male. And we've got 1, 2, 3 of them who speak English. So if we're doing a percentage, we've just got to multiply that by 100, which you can just do on your calculator, which gives you 75%. What is the modal category? So the modal means the mode of language spoken. So I'm just going to clear what I've just circled here. All right, so let's just highlight the number 1 occurs 1, 2, 3, 4 times, and it doesn't really matter what. 2 only occurs once, and then 3. Okay, so we can clearly see it's going to be English. Don't really need to keep highlighting them, but we can. Oh, I've already done that color. What haven't I done? What is this darker green? Okay, so English is the modal category. So we shouldn't say 1 because 1 represents English. Find the median distance that the students travel to from their home. So I would, because it's not in order, I would do that on the calculator. So let's go through how to do that on the calculator. Sorry, I'm just going to get rid of, oh, I probably shouldn't have got rid of the answer. Hopefully you've already written it down. All right. So just clearing what I had in before. So we go to clear. All right, so I'm going to type in very quickly all those distances. All right, 9 and 1.3. Just make sure I've got it correct. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Okay, so we go just to calc, 1 variable, and it's in list 1. And there's our median, 1.35. All right, so you could put them in order. If you wanted to order values on your calculator, you can also do that. Whoops. All right, so all we need to do is just go here and there we are. Let's put it in order. So there's 8 values, so we count 1, 2, 3, 4, so it's halfway between 1.3 and 1.4, otherwise known as 1.35 that we got before on the calculator. Find the range of the number of family members living at home. So remember, your range is the largest value minus the lowest value. So the largest value is 6 and the smallest value is 3. So our range is just 6 minus 3, which is 3. Oops, 6 minus 3 equals 3. Explain why it does not make sense to calculate the median of the phone numbers. Yeah, it just doesn't, because it's categorical data, basically. It's categorical data. Okay, let's move on because there's a lot of questions in this section. Now my computer told me I've only got 55 minutes of recording time, so we'll see how we go. All right, so the 5-number summary was determined from the sleep time in hours of a sample of 59 types of mammals. So you can see this was taken from the 2019, I'd say that means the Northern Hemisphere exam. Show that with calculations that a box plot constructed from this 5-number summary will not include outliers. All right, let's get some space here. All right, so outliers, so this is all in your notes. So your outliers, you need what's called your upper, oh, let's do the lower fence first. So your lower fence and your upper fence. Looks like I There. All right, so your lower fence is Q1 minus 1.5 times your interquartile range, and your upper fence is Q3 plus 1.5 times your interquartile range. So it's already told us that there are no outliers. So what I need to do is just calculate those two values and then say why there's no outliers. Okay, so interquartile range, let's just do it over here. So your interquartile range is your third quartile minus your first quartile. So what is that? 13.5 minus 8, which gives us 5.5. All right, so our lower fence, let's just call it LF. Q1 was 8 from memory. So 8 minus 1.5 times your interquartile range, which is 5.5. We'll do that on the calculator in a sec. And then your upper fence is 13.5 plus 1.5 times your interquartile range. Alright, so just calculating them on the calculator, go back to the main screen. So we've got 8 minus 1.5 times 5.5, and then we'll do the same for the other one. 13.5 plus 1.5 times 5.5. Alright, I'm just checking, make sure I haven't made any errors. 8 minus 1.5. Cool. So we've got negative 0.25. And what was the other one? 21.75. So basically anything below the lower fence would be an outlier. Anything above the upper fence will be an outlier. So we can see that the minimum is 2.5, which is not below, and the maximum is 20. So we can just say, I can't remember what the number was, 2.5. 2.5 is greater than negative 0.25, and 20 is less than 21.75, therefore no outliers exist. So just make sure you either use the inequality symbols or you can just write that. It's a bit hard to write on the screen, so I've just used the symbols. But you need to make sure you state why they don't exist, not just do the calculations. Oops, I think there was a few more questions, wasn't there? Copy the following number line and use it to construct a box plot. All right, I'm not going to copy it. I'm just going to draw it straight onto the screen. So there's no outliers. We've got a minimum at 2.5, so I'm going to draw a dot. We have a first quartile at 8, so I'll draw a dot there. Median is 10.5, which is there. Third quartile, 13.5. And then last, the maximum, which is here. All right, and then we just put our whiskers on. And then draw our box in the middle. Now you should be doing this with a ruler. All right, and yeah, going through those points. So it looks pretty symmetrical to me. There we go. All right, let's have a look at question 5. So we'll give ourselves a bit of space too. All right, is that the question I was doing? Okay. The unordered stem and leaf plot represents the number of points scored per match by the Blues in a disappointing football season. Oh, it's a bit harsh, a bit judgmental of this question. All right, display the data using an ordered stem and leaf plot. So, all right, we'll quickly do that. All right, we've got stem and our leaf. So we're going to have the same stem, but we're just going to put the values in order now. So instead of 5, 3, 9, we're going to have 3, 5, 9. And then we're going to have 0, 2, 7, 8. And then 1, 2, 4, 5. 1, 2, 4, 5, 7, 8. And then 0, 2, 3, 9. And then 2, 4, 9. All right, there it is, ordered. It's not too hard to put numbers in order. All right, how many matches were played in the season? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the reason I counted the first one as opposed to my ordered one, just in case I missed a number. So what was the Blues' highest score for the match? All right, so it's 89. It's not always going to be next to each other there. So you can see in my ordered one, we got 8 and then 9. So the last number is there. For what percentage of matches did the Blues score below 56? All right, so here's 50. So it's going to be a cut there. 1, 2, 3, 4, 5. So 5 out of the 20 games, multiply it by 100, and that's 1/4, so 25%. They scored below 56 points. What could best describe the shape of the distribution? Approximately symmetric, positively skewed, or negatively skewed? Mine, when I rewrote it, it looks okay. Like I lined up my numbers okay, but I would definitely go back to the original. It doesn't have to be in order, and you can see it's pretty much symmetrical. So you just turn the diagram onto the side if you need to. So it's approximately symmetric. All right, moving along. Let's just skip, give us enough space to write this. Remember, you should be writing these in your books. I didn't leave you enough room on the pages. So the development index for a country is a whole number between 0 and 100. The dot plot shown displays the values of the development indices for 28 countries. Using the information in the dot plot, determine the mode and the range. All right, so remember the mode is the most frequently occurring value, so we can clearly see that 78, and the range is the highest, which is 79, minus the lowest, which is 70, so that's 9. All right, question B. Write down an appropriate calculation and use it to explain why the country with a development index of 70 is an outlier for this group of countries. So this is where, so here's 70, so we're basically just calculating the lower fence because it's a lower outlier. So it's going to be Q1 minus 1.5 times the interquartile range. Now it hasn't told us what the lower quartile or the upper quartile is, but we do know there are 28 values. All right, so we're going to use that, 28 values. So half of 28 is 14, and it's an even number, so it's going to be halfway between the 14th and the 15th value. So let's count 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so we're kind of splitting it there. Let's just check that I've counted correctly, because this is an exam and it's worth 2 marks. I need to make sure I'm calculating it correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so our median is here at 76.5. Not that we need that for this question. All right, so Q1 is halfway between the lower half. So we've got 14 digits either side. So 7, now I'm going to count to 7. So half of 14 is 7. 1, 2, 3, 4, 5, 6, 7. All right, so it's going to be there. And then 1, 2, 3, 4, 5, 6, 7. All right, so your Q1 is 75 and the Q2 is 78. Now you could also put all these values into the calculator. It is quite time consuming, but you can also do that. All right, so 75 minus 1.5 times your interquartile range. Just make sure if you're doing that calculation here that you put it in brackets. All right, so 75 minus 1.5 times 78 minus 75 is 3, so 70.5. All right, so 70 is less than that, therefore it's an outlier. So we can just say 70 is less than 70.5, therefore it's an outlier. All right, I think that was the only question we had to do. Yep, sorry, I'm scrolling on and I didn't check. All right, question 12. Let's just move move this along though. Oh no, that's for the same, it's not for the same question. All right, and then, okay, on to that one. This table shows the percentage of women ministers in the parliament of 22 countries in 2008. So we've got country and country. Instead of having one long table, it's just repeated. All right, so it's not 4 separate things, it's just country and percentage of women. What proportion of these 22 countries had a higher percentage of women ministers in their parliament than Australia? So where is Australia? Okay, so we've got 24. So how many are higher than 24? Let's have a look. And it's had a higher, so it's not the same, it has to be higher. So we've got 1, 2, oh, it's in order, which makes it easier. All right, so there's 11. 11 here. And we can also see, because we're doing a percentage, that's half, and half as a percentage is 50%. Right, so we don't even really have to do much more than that. That was easy to see. Determine the median, range, and interquartile range of this data. Now, we're doing a lot there. So what I would do before I just go and think, oh, it's easy to just plug this into the calculator, let's just see what the next question is asking us. I can't scroll. We're doing, I don't think my computer's liking all these videos I'm doing. All right. Alright, so we're doing Canada. Alright, so the values are in order, so you don't necessarily have, it would be quicker to do on the calculator if they weren't in order. So I'm just going to show you both ways, because I think some people would prefer to just put them into the calculator while others can see they're already in order. So I've got 22 values. So they're in order, so halfway is going to be between 32 and 24. All right, because we've got then 11 values either side. So I can just add those two values up. So 32 plus 24, and then if we divide that by 2, that's our median, which is 28. I'm just going to write it here instead of scrolling. Median equals 28. The range is just your lowest value minus your highest value. So Norway has 56, Singapore has 0, so your range is just 56. And then the interquartile range, so halfway in this group here, our upper half, so there's 11 values, so we're going to find the 6th value, 1, 2, 3, 4, 5, 6. All right, there we go, Austria in the middle, and there's Ireland. So 38 minus 21 gives us 17. All right, if you were doing that on your calculator, you can just go to Menu, Statistics, clear what you've got there. Remember, if I'm going too quickly, you can easily just pause, or you can watch me in slower speed, probably. Don't think you would though. 56, 58. All right, so just quickly entering these values. All right, and then we can just go calc, and we want one variable. Okay, so what did we have to do? The median, there it is, 28. The range it won't give you one here, but that's easy. It's just your highest value minus your lowest. And then I'll give you the min and the max though. So there's your min 0 and your max. And then your interquartile range. So Q3 38 and Q1 21. All right, so you can enter the values in as well if you feel more confident doing that. All right, the ordered stem plot displays the distribution of the percentage of women ministers in Parliament for 21 of these countries. The value for Canada is missing. Copy and complete. All right, so we'll just put Canada in. So there's Canada, 16. It just says copy and complete because it's a textbook. On an exam, you would just have to put it on there. You wouldn't have to copy it. Both the median and the mean are appropriate measures of centre for this distribution. Explain why. All right, so remember we've discussed this before. So when it's approximately symmetrical, which it is in this one, then you would use either the mean or the median. And you could say because the distribution or the shape of the stem plot distribution is approximately symmetrical. And we can say without outliers. I don't think you would have to say without outliers, but we'll put it in there just because we want to be, yeah, because it's not affected by outliers. If you had outliers, you wouldn't use the mean. All right, now I might pause. Oh, so many questions to still go. All right, maybe we'll do one more in this video. Where are we? Okay. So I'm just doing a range of questions in these videos. Okay, let's have a look at this one and then I'll stop and we'll do a separate video for the remaining questions. The dot plot below shows or displays the maximum daily temperature in degrees Celsius recorded at a weather station at each of the 30 days in November 2011. From this dot plot, determine the median maximum daily temperature. Okay, so we've got 30 days. So remember the median splits it in two, so we're going to have 15 either side of the median. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's our split, and that's at 20. All right, so 20 degrees Celsius. The percentage of days on which the maximum temperature was less than 16%. Sorry, not 16%, 16 degrees. So we've got 1, 2, 3, 4, 5, 6, 7. So 7 out of the 30 days. All right, so we can just do that on the calc. Sorry, I should do times 100. Where are we? All right, 7 divided, oops, that's not a 7. 7 divided by 30 times 100. All right, so 23, and we're rounding to one decimal place, so 23.3%. Records show that the minimum daily temperature for November at this weather station is approximately normally distributed with a mean of 9.5 and a standard deviation of 2.25. So remember, when we see normal distribution and we've got our mean and our standard deviation, we draw our curve. So I'm just going to scroll down. Here's our normal distribution. Take the whole page. Remember, we've got to put the mean in the middle, 9.5, and we're going 3 standard deviations either side. All right, so here we've got a standard deviation of 2.25. Now, it's late in the day and I've done quite a few videos today, so I don't trust my calculation skills. Whoops. See, I keep pressing the wrong button on the calculator too. 2.25, so we've got 11.75. And then we're going to add 2.25 again, so we get 14. And then I can just press enter. 16.25, and then we can go in the other direction. So 9.5 minus 2.25, and then we're going to get 5, and then 5 minus 2.25, 2.75. All right, determine the percentage of days in November that are expected to have a minimum daily temperature less than 14. All right, so there's 14 at the weather station. So we want all of this. Now 14, here's your mean, is the 2 standard deviations above. So knowing my percentages, this is going to be 2.5%. All right, so you can refer back to your notes for that. Oh, is that all we have to do? Just 2.5, because it's asking for the percentage of days. So 2.5% of those days are going to be less than 14 degrees. All right, beautiful. All right, nearly 30 minutes, which is good. We'll end it there. Bye, guys.